So we're starting with factoring because this is one of those skills that you should have seen before, at least in different incarnations, and we're going to be slowly adding some pieces of work to it and some tools to it. So the first one, this should be review for everybody. What tells me how to handle this is that I see that I have an x squared and I have an x. When I see both the x squared and the x there, that tells me that I'm going to be factoring this into two different sets of parentheses, each one with an x in it. And the numbers that go in the parentheses are the two numbers that add to the middle number and multiply to the last number. So what adds to negative 13 and multiplies to 40? Now in this case, since I'm multiplying to a positive, that means both signs must be the same. And since I'm adding to a negative, that means they both have to be minuses. More specifically in this case, 5 and 8. So we end up with x minus 5 times x minus 8. For the second problem, notice this one is not x squared and x. It's x to the fourth, x cubed, and then just a number. So I can't necessarily do what I just did on this one. But what I can do is look at all three of those terms and divide them all by the same thing. What are all three of those terms divisible by? 3, yes, but also 6. Yep. And I want to go with the biggest one every time. Now, if you don't pull out the biggest one, you'll notice that in your answer you can pull out something even more. And so you'd have to just take a separate step after you did the first one if you didn't pull out the biggest at the start. So I'm going to factor out a 6. Now, when I do that, the first thing I do is I write the 6 and then I start a set of parentheses. Because factoring is distributive property backwards. So rather than multiplying something into parentheses, I'm dividing something out of parentheses. And now I divide all three of those terms by that 6. So 18 divided by 6 gives me 3, so that's 3x to the fourth. Minus stays the minus. 24 divided by 6 is going to give me 4, so that's 4x cubed. Plus is still a plus. And this is the part that sometimes trips people up. 6 divided by 6 is 1. Sometimes people think, oh, well, I'm just taking the 6 out, and so they just leave it out completely. But if I'm going to multiply that 6 back in and get 3 terms, I got to have 3 terms in those parentheses too. I have to have something to multiply the 6 to. So that's why we still have to have the 1 in there. And notice that if I take a look inside at each of those numbers, the 3, the 4, and the 1, I can't divide them all by anything else, either 1, which doesn't matter in this case. And so then that tells me this is in fact the final answer. It's as good as that one got. Now number 3 is actually a combination of those two. Number 3 might have gotten you stumped at first. But that's because of the 2 in front of the x squared. If there's a number in front of x squared, I cannot simply say what adds to the middle number and multiplies to the last number. But I can actually get rid of the 2 in this one. Because you notice every term is divisible by 2. So I'm going to do that first. I'm going to factor a 2 out of that equation. And so if I do that, the 2x squared just becomes an x squared. Because I'm doing 2x squared divided by 2. Or in other words, 2 times what will give me 2x squared. So that's why it's x squared. Then I do the same thing for the 26x. That becomes 13x. Minus is still minus. 60 divided by 2 is 30. Now you'll notice that inside the parentheses here, I have a quadratic like I had a number 1. That quadratic is factorable. I have the x squared and then the x. So I can do the add 2 multiply 2 thing again. So when I do that, the 2 just hangs out up front, and then I set up my 2 parentheses, each one starting with an x. And in this case, I'm saying what multiplies to negative 30 and adds to a positive 13. Watch your signs when doing this factorization, because it's not 3 and 10. Instead, because it's a negative 30, that means one number has to be positive and one of them has to be negative. And in order to get the 13 there, that means it has to be a negative 2 and a positive 15. So that would be the totally factored form. This part is somewhat new for us right now. It's just adding a layer onto some of the stuff you've done before, or it is review, just depending on kind of where you went before in your particular Algebra 1 class. All right, today we're going to be seeing how to graph problems that look like this. What makes this different from anything we've done before is that 2 that is multiplied by x squared. The only thing we've ever had in front of x squared up until now was a negative. All right, so in order to graph this, I want to start by just thinking about what does the table normally look like for this. And so you'll notice that what we're looking at right now is the standard x and y, the x and x squared that we get when we graph just y equals x squared. So this is what we graph for just y equals x squared. So we start 0, 0, then we go over 1 up 1, over 2 up 4, over 3 up 9, etc. Now what we're doing in this case to get this y value is we're multiplying it by 2. So I now need to take each of those x squared values and multiply them by 2. So let's go down the list and go ahead and do that. So first of all, I do 0 times 2. Well, of course, that's 0. Then I do this 1 by 2. So that gives me 2. Now I'm multiplying this 4 by 2. And so that gives me 8. And notice I'm just going to go down that list and multiply each of those by 2 to see what my new y value would be. These are the y values I'm going to be plotting for this particular graph. So in making this graph now, I'm graphing these x's versus these y's. The x squared column there was just an intermediate one showing this is what I get when I do x squared. Now I have to multiply it by 2 to get my actual y value. So I can plot those points. So let's go ahead and do that. So we start with the point 0, 0. So that didn't change, notice. The vertex didn't move. Then I go to the point 1, 2. And then we go to 2, 8. And then I go to 3, 18, but that's off my graphing grid, so I'm not going to worry about plotting that. So I'm going to jump down to the next that I can plot, which is going to be negative 1, 2, and negative 2, 8. And once again, negative 3, 18, that goes off my graphing grid, so I don't need to worry about that. Now, when you plotted those points, you go ahead and draw your curve that goes through them, and this is what you're looking at. And now, we just applied a single transformation to this when we multiplied it by the 2. So now we need to describe that transformation to see how would we describe what just happened. And what I want you to notice as you take a look at this graph is that the point that was up 1 is now up at 2. The point that was up at 4 is now up at 8. Each of the points is now twice as high as it was before. It did not make it more narrow, it made it taller. That's an important distinction there. And so when we describe this transformation, we describe it as a vertical stretch by a factor of 2. So it's vertical because it's affecting how tall it is. A stretch means we're multiplying it by something. So it's like I'm grabbing the top of my graph and I'm pulling it up to be twice as tall. And we always want to say how far it is. Just like I never say the graph moved left, I say it moved left this far. In the same way, when I vertically stretch it, I need to say by what factor. Basically, the factor is what you multiply it by. So that's why this is factor of 2. All right, now having done that one, if you can make that graph, you can actually make this graph as well. So write down this equation above your next graphing grid. And so the reason why we can graph this now suddenly much more complicated looking equation is that you already know what everything else does in this. The minus 4 does the same thing it used to do. So the minus 4 in with the x is still going to move it to the right. And the 3 that's out front doesn't change how far it goes over. So it's still going to go right 4 units. The minus 8 hanging on the end, it doesn't do anything different than what it did before. It still does the same thing. And that is, it moves down. Specifically, it's going to move it down 8 units. So notice my vertex still starts at the same location. However, we do have that 3, which is our new piece. That 3, just like the 2 is a vertical stretch, the 3 is a vertical stretch. And so it's going to be stretching it up and down by a factor of 3. So I'm going to be multiplying how far I go up or down by 3. So let's actually then apply that to make this graph. So we know we go right 4 and down 8. That's where you put your first point. Go right 4, down 8 for your vertex. Now normally from there, I'd go over 1 and up 1. But I'm not going to in this case. Because in this case, I have a vertical stretch by a factor of 3. So notice vertical stretch. It doesn't change how far I go over. So I still go over 1. But instead of going up 1, I'm going to go up 3. Because I'm multiplying however far I normally go up by 3. So I go over 1, up 3 from my vertex. And I know it's going to do the same thing on both sides, so I'm going to go ahead and put the other side in there. All right. Now let's take a look and see what happens if we go over 2. So if I go over 2 now, normally I'd go up 4. I'm not going to in this one though. Instead of over 2 up 4, I'm now going to go over 2 still, because it's not affecting how far I go over. But instead of going up 4, I'm going to go up how far?
6.
Nope.
12.
I normally go up 4. I multiply that by the 3.
12.
So it is 12. Yep. So I go over 2 and up 12 now. Now when you draw on the curve for that graph, this is what you should be looking at. So make sure you have that graph totally correct. Notice I wasn't able to plot anything past the over 2 up 12, because after that it would have to be over 3 and up 27, and that definitely did not fit on my grid. It'd be 27 because normally it's up 9, and this probably multiplied the height by 3. Alright, next equation. Please write this above your next graphing grid. Y equals 1/2 x squared. Alright, now in order to do this graph, again the 1/2, it's going to do the same kind of thing that the 2 and the 3 did before. It's affecting what we go up by. It's multiplying what we go up by each time. And so notice there's no shifts here, no plus or minus, so my vertex is still going to be at 0, 0. But I'm not going to go over 1 and up 1. Remember that the 1/2 multiplies how far we go up by a half in this case. So instead of over 1 up 1, I'm going to go over 1 and up a half. Yes, we are plotting it at a half. Okay, next up. Normally, I would next go over 2 and up 4. That's what I normally do. But in this case, I got the 1/2 there. Remember, the 1/2 is multiplying or up by a half. So I'm still going to go over 2, but instead of going up 4, half times 4 gives me 2. So it's over 2 and up 2. All right, next point. If I go over 3, I normally go up 9. I drew that in the wrong spot. There we go. So then in this case, I'm still going to go over 3, but instead of going up 9, I'm going to go up how far?
4.5.
4.5. 4.5. Yep, because 9 times a half gives me 4.5 right there. And then we can just keep plotting these points as we go along. So over 4 is normally up 16. What's half of 16? 8. So it's going to be over 4 and up 8. And I can do that on both sides. Over 5 would be up how far?
25.
25. And half of 25 is 12.5. So I'm finally off my graphing grid. So I can go ahead and draw my curve and that goes through those points. So this is what you should be looking at for your graph of y equals 1/2 x squared. Now again, think about how would we describe the transformations. This is working just like the 2x squared was. It's multiplying it by it. And for that one we said it was a vertical stretch by a factor of 2. But it doesn't necessarily make sense to say that we're stretching it by 1/2, because when we stretch something we're making it bigger. And this is actually making it smaller, notice. It's squishing it down. And so when we're multiplying by something between 0 and 1, like a fraction like this, it ends up making it smaller. So we end up describing that as a vertical compression by a factor of 1/2. So the compression is making it smaller, the stretch just makes it bigger. All right, now it's time for our last one to pull the pieces together again. So please write down this equation above your next graphing grid. And I think you should be able to go ahead and graph it all on your own, so go ahead and make that graph. All right, so for making this graph, we get to our vertex the same way. The -5 moves it right 5. The -4 moves it down 4 to get to our vertex. So I go right 5, down 4, plot a point. Now the 1/2 is a vertical compression. It's squishing it in. So instead of over 1, up 1, I'm going over 1, up half as much. So up a half. And then instead of going over 2, up 4, I'm going to go over 2 and up 2. Again, I'm going up half as far. And then over 3, instead of going up 9, I divide the 9 by 2, so I'm multiplying it by half. Just like we did on doing that 1/2 x squared, we're following that same pattern from there. So this is the graph you should end up with, point by point. And then once you have that, we're going to go through the rest of these details. All right, now taking a look at some of these other questions, the transformations. How would we describe the transformations for this? Well, the 1/2 would be a vertical compression by a factor of 1/2. The -5 is a shift right 5, and the -4 is a shift down 4. Okay, fine. Which means our vertex was going to be at 5, -4. But now axis of symmetry, we haven't talked a lot about that one. I want you to be able to visualize what that's talking about. So axis of symmetry, basically it's just the vertical line that passes through the vertex of our graph. And it's called the axis of symmetry because you notice it is symmetrical to the left and to the right of that line. So the axis of symmetry is just the equation of that line that I just sketched in. Well, it's a vertical line, which means it's going to be x equals. And for every point along that line, x equals 5. So we got x equals 5. Then the range, well, all of our points are above -4. So our range is going to be that y must be greater than or equal to -4. So then those are those little details as you take a look. You might want to add those into your notes and next to your graph so that as you're asked questions like this on your homework assignments and tests, quizzes, and all that kind of stuff as we continue to discuss it, you'll have examples. And plus, these are really those pieces that tie other parts of these quadratics together.